So this is just a quick summary of everything we've learned when it comes to reduction formula and the Cartesian plane. So just have a quick look there and just remind yourself again of the Cartesian plane and of this course diagram, all stations to Cape Town. We said in the first quadrant, all ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, cos is positive. We can define this first quadrant as all angles that are theta. The second quadrant is 180 minus theta. The third quadrant is 180 plus theta. And the fourth quadrant is 360 minus theta. If we are looking at cofunctions and the cofunction rule, we can write this quadrant as 90 minus theta and this quadrant as 90 plus theta. Our cofunction rule, remember, states that sine changes to cos and cos changes to sine when the angles are complementary. So when we are working with 90 plus theta and 90 minus theta. Then we do that change with sine and cos. We also did negative angles, and for those of you who were in the lesson, and for those of you who are still going to watch the lesson on the website, when we do negative angles, we are just rotating in the clockwise direction. And when we rotate in the clockwise direction, a negative angle would be this, like this example over here that I've just drawn. And then I'm just actually, if it's a negative angle, it is just actually in the fourth quadrant. So sine of a negative angle is negative, cos of a negative angle is positive because it's in the fourth quadrant, and cos is positive in the fourth quadrant, and tan of a negative angle is negative tan. Then we looked at angles greater than 360. So angles greater than 360 just means I've rotated right through the Cartesian plane and have now ended up back in the first quadrant. Okay, so 360 plus theta is just an angle that is greater than 360, and that is normally in the first quadrant. So sine, cos, and tan are all positive for angles greater than 360. And that in a nutshell is reduction formula. And now we are going to do quite a few examples to practice this and to get this ticked off our list as we move through this foundational course on trigonometry. Remember, this is a foundations course, meaning we are preparing and we are revisiting and re-looking the things you might have missed from the last 2 years in trigonometry, because we can't really progress if we are missing those foundations. So they are super important. Okay, I'm going to do the first 2 questions, I think, with you, and then I'm going to leave you on your own to try the rest. But before I carry on, please can I have a thumbs up in the chat to see how everyone's doing with our trig reductions so far? Thumbs up or thumbs down? I just want to see where everyone's at. Wonderful. Thanks, Buchle. Nawazi says all good. Thumbs up. There's a good few thumbs up in the list here as well. So Lolita, Mache. Okay, Neo, somewhat good. Thanks for your honesty. Jessie, Valerie, awesome. By all means, if it's not a thumbs up, then you can also tell us. Sichle, Lakuma, well done. Okay, right. So let's get into it. And I am going to do this first question over here. So sine 90 plus theta. Okay, so our thought process is always the same. It can only be one of the few things that we have set out and summarized here below here in our list. Okay, it can only be 180, 360, those rules for reduction. It can only be a negative angle, an angle greater than 360, or a cofunction. Okay, so clearly here we've got to do with the cofunction, because sine 90 plus, that should immediately jump out to you and shout at you cofunctions. So how are we going to reduce this? Sine 90 plus theta. So if we scroll up here to our quadrants, 90 plus is in the second quadrant, but sine must change to cos. Please feel free to post your answers as you're working out. Post them in the chat. We want to see your answers. We want to know what you're thinking, what you're doing, and share it with the class. Sine 90 minus theta, that is in the first quadrant, but it's also cofunctions. What am I saying? I'm saying one thing and writing a different thing. So sine 90 plus theta must change to cos theta. I'm talking so much about cofunctions, I forget to actually do them. Okay, and then sine 90 minus theta, that is also the cofunction rule. It's in the first quadrant, and sine is going to change to cos. And what have I got now? Cos theta divided by cos theta is 1. Okay, Michelle, it won't be -1 because sine in the second quadrant is positive and sine in the first quadrant is positive. We always take the sign, if it's positive or negative, of the original function when we apply the cofunction rule. Yeah, cos, if it was cos, then that would be it. Okay, so that was a tiny warm-up. Let's step it up a little bit into the next one. Okay, so our thought process here is cos 180 minus theta. 180 minus theta, that is the second quadrant. Cos in the second quadrant is negative, so we make it negative cos theta, and the 180 just falls away. I like to put brackets around everything that I replace or change so that I remember I'm multiplying. You don't have to. It's just something I do that my teacher back in the day when I was in grade 11 showed me, and I still do it. So you can follow my example with the brackets, or you can leave them. I know the previous lesson, some people were asking about the brackets, and okay, so don't get confused with the brackets. Okay, so cos 90 minus theta. Cos 90 minus theta, immediately now you must also think again cofunctions. Okay, and cos in the first quadrant, because 90 minus theta is the first quadrant, cos in the first quadrant will change to sine theta. And it will stay positive because cos in that quadrant is positive. Sine 90 plus theta. Sine 90 plus theta, that is the second quadrant, but we must apply the cofunction rule again. Cofunctions. So that's going to change to cos theta. Okay, now what have we got here? Sine theta minus 180. So sine theta minus 180. A little trick here. We are obviously used to seeing 180 minus theta or 180 plus theta. This is a negative angle, but what we can do to actually help us know, because this isn't immediately clear what quadrant that is in. So to help us, what we can do is just add 360 degrees to it. So I'm going to do it on the side here. And it is something, it's a trick or a technique that you can use in trigonometry, because 360 is just going to make it sine. By adding 360 degrees to it, it is just going to make it easier for ourselves. And that's going to turn it into sine theta plus 180. Okay, now theta plus 180, that is easy, right? We know what quadrant that is in. That is actually in the third quadrant. And sine in the third quadrant is negative sine theta. Okay, so that is something you can do. Just if you see something that looks weird or strange or doesn't quite work into the four quadrants the way you are used to them, just add 360 degrees to it, and that will normally solve the problem. Okay, so Kayla's asking, why doesn't it change to a negative? Because it's in the second quadrant. I'm talking about the cofunction we just did.
I think she means the sine 90 plus theta.
Okay, so sine 90 plus theta is in this quadrant over here. Remember, with cofunctions, we always look at the original function. If that was cos 90 plus theta, we would change it. But sine in that quadrant, that's the second quadrant over here, sine is positive. So that's why we change it to cos, but we leave it as positive, because for cofunctions we only use we use the sign of the trig function, the original one. So because sine is positive in the second quadrant, we leave it positive. Okay, right. And what have we got here? Everything is just going to cancel, and a minus will make it all positive. So that's going to be 1. Okay. Right. How's everyone doing so far with that? Please put it an emoji in the chat so that we can see how you are doing, grade 12s. Let us know. Thumbs up from King Zooks. Wonderful. We've got 3. So far, so good. Wonderful. Okay, so I'm going to leave you alone for about 3 minutes to start question 3 on your own now. And when you have an answer, post it in the chat. Then we can see how you are doing. We love to know how you're doing and what you are doing and what you are thinking. Please share it in the chat. Okay. I'm going to be quiet now for 3 minutes while you think and work. If you've just joined us, everyone is busy working on question 3. So even though you've just walked in, maybe, please get going and try and do question 3. Remember, grade 12s, put your answer in the chat so that we can see what you get. We are off. We've got some answers. Many seem to be getting tan of x. Okay, I'm going to give it 30 more seconds and then we can see what is, if these guys are all correct. Okay. Right. Okay. So we are going to reduce cos of 180 minus x. We reduce that to negative cos x because cos in the second quadrant is negative. Cos 90 minus x is going to reduce to sine of x. It's sine of x because that's the 90-degree rule. And then tan of a negative angle is negative tan x. Remember, a negative angle is in the fourth quadrant, so tan is negative in that quadrant. Sine of 180 plus x, that is the third quadrant. Sine is negative in that third quadrant. And then sine of 90 plus x, that's going to change to cos x. And we can cancel out sine with sine, but there's a negative left, cos with a negative, and a negative and a negative and another negative will make our whole answer negative tan x. Well done, everybody. You got that right. That's really good. Well done. Excellent. Okay, are we ready for something a bit more challenging? Good job, everybody. Well done. Okay, so the principle remains the same. We just keep adding more stuff to it. So here's question 4. Again, I'm going to leave you to it for about 3 minutes and let's see what you get. Remember to put your answer in the chat as soon as you're ready. Yes. That's good advice, Ms. Nicole, to use the brackets to keep track of the sign changes. Because yeah, that can make a difference to your answer and can make a difference, obviously, to the marks that you get. Okay, I am going to start showing some of the working out, and then you can check as I go if you agree with what I got. Remember, for cofunctions, we take the sign of the original trig ratio or trig function. Please don't. As I wait, Neo. Okay. I'll write slowly. Okay, time is almost up, guys. I want to see if anyone gets the answer here. Waiting in anticipation. I'm not going to go further. I'll wait for everyone. Bouchle, tan is positive because this quadrant, let me just grab my highlighter. This one here. Remember I said in the previous example as well, we can add 360. We did it over here as well when we had sine of theta minus 180, and then we added 360 just to make it look like something that's a bit more familiar and a bit easier to work with. And you can always do that. You can add 360 if it's the wrong way around, or if you want to, if this is a negative angle and you want to see what quadrant this is actually in. So this actually, just like in the previous example, it works out to tan of 180 plus theta. And that means, I'm just reading the answers, sorry, while I'm explaining this, that means tan is positive in that quadrant. Okay, so everyone's getting some answers, but it's all different, it seems. Okay, let's see. Okay, I'm going to finish it. Let me talk through each one of these. So cos 90 plus theta is going to change to sine theta. We make it negative because cos in the second quadrant, 90 plus theta is the second quadrant. Cos in that quadrant is negative, so that's why it's negative sign. Okay, some people, I think the closest one so far is my answer is 2. That is the closest one so far. Okay, then tan 360 plus theta. Remember what we said here about angles greater than 360? That's just actually in the first quadrant. So tan 360 plus theta is positive. Okay. We put the minus down because that minus is there, but then we do our reduction of sine 360 minus theta. Sine 360 minus theta is fourth quadrant, and sine is negative in that quadrant. And then tan of 180 minus theta is negative. Okay, now we need to sort out our signs and simplify and remove brackets a little bit. So we get minus sine theta, tan theta. Minus times a minus is a plus. Times this minus here will make it minus sine theta, tan theta. Okay, so that's what we've got so far. And then at the bottom, we've got the same, minus sine theta, tan theta, which will make everything negative. Okay, so now this is basically just like terms. Minus sine theta, tan theta, minus another sine theta, tan theta is just minus 2 sine theta, tan theta. And at the bottom, we've got the minus sine theta, tan theta. Okay. And with that, then we can cancel out the sine and the sine and the tan and the tan. And minus 2 divided by a minus 1 will give me a 2. So where is that person who got 2? I saw one person said they got 2. A virtual chocolate for you. Well done. I've lost that person now, but yeah, that is what we do. Wonderful, wonderful. Okay, that's 2. So you see that the brackets come in handy because they help you with the sign changes. Cassandra, you say you lost me. Where exactly? I don't want to re-explain everything. I did go through them one by one in terms of how we got to each of these. So maybe I can take it from step 2 here, where we changed the minus and the minus. That was a plus with another minus in front. So that's why we get minus sine theta, tan theta over here. And then minus sine theta, tan theta. It's the same as like saying minus xy minus another xy. That will give me minus 2xy. They're just like terms. The trig functions with the theta, it's just like terms. So it's the same as saying minus 2xy divided by a minus xy. It's the same thinking. So back to your grade 8 algebra where you learned how to simplify these things. It's the same, they're just trig ratios now. Why don't the like terms cancel? They don't cancel because we've got minus sine theta, tan theta, minus another sine theta. So now I've got minus something, minus more of that. So it's minus 2 of those. And then they do divide out here in the second last step, where we go sine theta divided by sine theta and tan theta divided by tan theta. They do divide out over there. And then a minus divided by minus will give you a plus. Okay, I think I've dealt with all the questions in the chat. There is a hand up. Let me see whose hand is it. Okay, Ketelwazi, you can unmute and ask your question.
Hey, ma'am. By the third step, ma'am, where you highlighted that sine theta brackets tan theta. I don't get how we went from the second step from minus bracket minus sine theta brackets minus tan theta to now minus sine theta bracket tan theta again.
So that basically comes from the previous step over here. Okay, so you see that a minus and a minus make a plus, so that's why it's positive. But then we still have this minus, so that makes it negative over here. And then minus sine theta tan theta minus another sine theta tan theta gives me minus 2 sine theta tan theta. And I explained it here just with some basic algebra, some basic ideas. Minus xy is minus 2xy. So that's how we got to that. Okay.
Yes, ma'am.
Okay, does that make sense?
Yes, ma'am.
Okay, good stuff. Right, so it's good you guys are asking these questions so we clear this up and we get you on your way to doing grade 12 trigonometry. Because remember, all of this reduction stuff is still in your grade 12 paper as well. Okay, now let's move on to some numerical reductions. Okay, we haven't done these yet in this course. So now we are going to use what we know with reduction formula and special angles. So we're going to use our special angles and our reduction formulas together. Okay, and I'm going to do this first one with you. I'm going to do it on the side here. So tan 135 plus tan 225. So we need to reduce these or simplify these without a calculator. So the minute you hear without a calculator, it means you're either drawing a sketch or you are using special angles. In this case, we're not going to draw a sketch. We are going to use special angles. So we start with the tan 135. And I'm just going to go fetch our, and copy it over, our Cartesian plane from our previous lesson or from our previous page, because we are going to need it again. Okay. So if we start here with the tan 135, so this is our thinking process. We go, in what quadrant is 135 degrees? 135 degrees will be here in the second quadrant, because you'll rotate past 90 and into the second quadrant. The second quadrant is the 180 degree minus theta quadrant. So what you ask yourself is, what must I subtract from 180 degrees to get 135? 180 degrees minus how much is going to give me 135? And I've got Neo saying it's 45. I agree. So we reduce this then to 45 degrees, but tan in the second quadrant is negative. So we reduce it to negative tan 45. Okay, now we're going to go through that same thought process with 225. 225 is in this quadrant here, in the third quadrant. And this is the 180 plus theta quadrant. So what must I add to 180 to get 225? Again, it's 45. Tan in that quadrant is positive. Tan in the third quadrant is positive. So we can reduce it to tan 45. Now we use our special triangles to work out what tan of 45 is, because 45 is a special angle. And if you are new and you missed the lesson on special angles, please go and watch it so that you can catch up on that part. It is available on our website. Okay, so tan 45, tan of 45 is just 1. So you can use your triangle. 45 is opposite over adjacent. That's 1 over 1. So that's minus 1 plus 1 is equal to 0. The answer is 0. Good stuff. Okay, let's try the next one. Everybody on your own. I'm going to give you 2 minutes. You go through that same thought process and you don't use your calculator. You only use your triangles to do question 2. Put your answer in the chat when you are ready. Some answers are coming in already. Minus 1, 1. And I'm wondering, these answers came in fast. So I hope we did not use our calculator. Okay. So let me rub this out from the previous question. Okay, so 330 degrees is going to be in this quadrant, in the 4th quadrant. And I can get 330 by saying 360 minus 30. Sign in that quadrant is negative. So we reduce it to negative sine 30 degrees. Okay, cos of a negative angle, let's sort that out first. Cos of a negative angle is positive, and there's also a minus in front, so that will make everything negative. Cos of 60. And now we can use our triangle to do minus sine 30. Sine is opposite over hypotenuse, so that is minus a half. And cos of 60 is adjacent over hypotenuse, so that is also a half. So answer is 0. No, not 0. What am I saying? It's minus a half. It's minus 1. There we go, minus 1. Minus 1. Well done to you guys who got minus 1. That's good stuff. Why is it not positive 60? Because cos of a negative angle is positive, but there's a minus in front of that cos. So we'll end up with sine 330 minus cos 60. That's why cos of a negative angle is positive. Okay, let's go on to the next question, and I think this might be our last one for the evening. No, we might be able to do these both. Okay, let's go on to question 3. Put your answer in the chat when you are ready. Okay, remember, with an angle greater than 360, like cos 660, you say, what did you add? That is 360 plus. So first do that step. If you've just joined us, I see there are a few new people who have just joined. We are doing question 3. We are practicing our reduction formula and doing numerical reductions. Put your answer in the chat if you are ready. Aha, Bonnie, well done. Good stuff. Before you did too much work, I hope you noticed that it is undefined. Why is it undefined? Because sine of 180 is 0. So that is undefined. For those of you who did carry on, I can show you what to do with the negative. Yes. Tandalweta also saying, and Valerie also saying no solution. Okay. Well done. So you could have carried on and reduced the 120 and the 300 and the 315, but in the end, it would have made no difference. It is undefined because sine of 180 is undefined. Okay. Last one for this evening. I think we have time to do question 4. We won't have time for question 5, but let's give question 4 a go. Well done, grade 12s. You are doing an excellent job this evening. Keep going. One last one before we call it an evening.
I think you're on mute, teacher.
Lovely having a conversation here with myself. Yes, Michelle, if we reduce sine in question 3, it will reduce to negative sine 60. And if you reduce cos 300, it would also be cos 60. And tan will be negative tan 45. Okay, just in the interest of time, I'm going to start doing this one so that we get it done before we have to end. So sine 170 degrees, sine 170 will be in the second quadrant, and we can reduce sine to positive sine 10 degrees. Cos of 315, that will be in the third quadrant. So we say 360 minus what will give me 315. Cos is positive, and that is cos 45. Tan of 390, this is an angle bigger than 360. So what will you add to 360 to get 390? That will be 30 degrees. So that reduces to tan 30. Okay, so I hope you see that we need to 45, 30. This sine 10 over here is looking a little bit out of place, but I think all will reveal itself, especially when we get to cos 100, because cos 100, that's going to be in this quadrant here. And we can remember this quadrant can also be a cofunction quadrant, 90 plus theta. And if we look at 100, we can say 90 plus 10 will give me 100. And if it's 90 plus, cos changes to sine, and cos is negative in that quadrant, so it's negative sine 10 degrees. And now it's making a lot more sense because we're going to end up cancelling those out. And then sine of 225, that's in the third quadrant, so that's negative sine 45 degrees. Okay, still no calculators allowed. A negative and then negative at the bottom, we know that's going to make the whole bottom positive as well. Our sine can cancel with sine. And then cos 45 and sine 45 can cancel. They are cofunctions. Remember, the angles add up. The angles are complementary. So that will cancel. So without even doing much further work, you can cancel them out because you know that they are cofunctions and the angles are complementary. And then all that's left for us to do, and I think some of you got this one right, is the tan 45. Tan 30. So tan 30 is opposite over adjacent. So that's 1 over root 3 for tan. And some of you got that, which is excellent. 1 over root 3. Wonderful. I see some answers in the chat. That's the same as mine. Wonderful. Excellent. Well done, guys. Okay, well, that is the end of our lesson this evening. We've done quite a bit.
Mom, I actually just wanted to ask.
Yes. Yes, go ahead. Go ahead.
Ma'am, so with my sum, I didn't change the cos 100 to negative sine 10. I changed it to negative cos 80. Are you still allowed to scratch out sine
Yes,
10
because
degrees and negative
yes,
cos 80?
you can.
Or is it wrong?
Yeah, because sine 10 and cos 80 are complementary, so that also divides it. Perfect. You can definitely do it that way. Okay, there's one more question. I'm just going to let me just see. Noor Hangani, do you want to ask a question? You got your hand up. Okay, I'm not sure why you're not answering. Nawazi, how? I assume you're asking about the cos 80 and the sine 10. It's because of the 10 and the 80. They are complementary, and that is why we can cancel them out if it's sine and cos. Okay. Right, guys, we have come to the end of our lesson. Thank you so much. We'll see you back here again on Thursday, and I hope that you have a good week till then. And remember, Thursday is also quiz day, so be ready for your quiz. It will be on all of this on Thursday. Okay, thank you so much, and have a good week. Ciao, everyone.